In our last example, we solved for future value, and we got a little sophisticated with payments and timing and interest rates, and it was an awful lot of fun. Well, in this one, let's do the same kind of thing, but look at present value instead. So if we remember, if I give you 4 variables, you can find the 5th pretty easy and straightforward. That time value of money outline, always draw it, label your variables, label that cash flow in, cash flow out. Remember, when money leaves your wallet, it's going to be negative. When it comes in your wallet, it's always going to be positive. So let's tackle a present value question and see how we do. You made an investment that's going to last for exactly 30 years. It promises to pay you $1,300 at the end of each year. So every year, $1,300, $1,300, $1,300, $1,300. What is it worth today to an investor with a 7% discount rate? And you may be saying, Craig, what on earth is a discount rate? Well, here's how I describe a discount rate. A discount rate is a rate of return you would expect on a project of equal risk. So projects of equal risks, investments of equal risks are yielding 7%. So in this case, we would use 7% to find the present value and discount back that return. All right, next thing we're going to do is we're going to go ahead and plug in where these variables are going to go when we hop to Excel. N is 30. Straightforward, right? We have 30 years, boom, boom, boom. We know that it's an ordinary annuity, right? It's going to be paid at the end of each time period. We know that once we're done with all the payments, there's nothing left in that account. It's going to be 0. And we know each payment is $1,300, and that's positive because those $1,300 come into our wallet. It's pretty straightforward from this point. Let's go ahead and hop over to Excel and dive on in. But one more time, N is 30. 7 is going to be I, 0 FV, 1,300 is going to be payment. And if we hop over to Excel, and I'll show you in just a moment, that present value comes back at negative 16,132. And I think it's important to talk a little bit about what that means. What that means is that this stream of 30 cash flows at 1,300 a year is equivalent to 16,132. So if I were to offer you either, mathematically, they're the same. You either take your $16,132 now, or you take 30 $1,300 cash flows. They are equivalent because that discount rate of risk matches other investments with the same level of risk. All right, so let's hop over to Excel and we'll go ahead and knock this out. So we have a 7% discount rate. We're going to put that into that effective rate field. And 1 compounding per year, 1 period, nothing fancy, no fancy math there. That rate is going to be 7. We know we get 30 years of these, and we're going to get that $1,300 a year going right in the wallet. And then the last question is an ordinary annuity or annuity due? And it's going to be an ordinary annuity. So it's actually pretty easy once we get to Excel to find that answer. But again, that discount rate is the important learning fact here. It's that rate that we could get on an equivalent project at 7. And you can see how it's going to change a little bit. If it's a riskier project, so let's say that the equivalent rate would be 8, or let's even go to 10, you can see that present value drops a lot because it's just not worth as much when there's more risk. On the flip side, if it's a really safe project, you can see that it's worth quite a bit more because there's less risk applied.